Okay, welcome to another episode. I apologize, my headphones I dropped in water, so hopefully the audio quality is good. Haven't made videos in a while. I think I made one yesterday, but I still feel like mentally I'm just not prepared to start making serious core content for this channel yet. So this video is going to be more another math video, just doing some pretty simple math to kind of just get me back into making videos and used to having my mind in the correct state while I make these videos. So we're gonna go all the way back to third grade math, learning about fractions, simple number literacy, which I recommend anyone do. I gave a speech on this in my last video. Knowledge is knowledge and knowledge is power. So if it comes from an unexpected source, like Khan Academy, which might at first glance appear to be directed towards kids, but if you read into it deeper, it's actually stated on the site in numerous places that it is for all ages. So in my mind, just the benefits of learning math are great enough to overcome any embarrassment of using a source that might be directed for kids. To the point where I live it, I'm making this public out there for everyone, so I'm hoping this video can be an inspiration for anyone who would like to learn something, but maybe is kind of turned off from learning because they realize that their existing knowledge set is just at a lower level than they had realized. Okay, so we're going to go do the mastery challenge because the goal is to master everything. So I've got second grade mastered. I've got sixth grade mastered because a few years ago I had that goal and I worked towards it. So I got pretty clear into the high school territory, some into the college territory. In my formal schooling, growing up, I studied through calculus BC, but all knowledge of that in my adult years right now is pretty much lost. One more thing I'd like to say before I get into the kind of nitty-gritty of really doing these problems. Why am I doing this? Why am I even willing to perhaps embarrass myself by studying third grade math in public? Because I don't have a bachelor's degree. I have a associate's degree in applied science. That's how I got my start in tech. And I think a bachelor's degree could potentially take me to places that I'm right now not as able to go. So if I want to get a bachelor's degree in like computer science or computer engineering or something to help further my current career trajectory, it's going to have a lot of math in it. So the more math I know before I enroll in the program, the easier the program is going to be for me. So that's my reasoning for doing this. Other people might have different reasoning, but in my mind, learning math is something I really respect in people. I do realize that some people do have conditions like dyscalculia, which can make basic arithmetic very difficult and can make it longer to do problems and to make them more prone to making mistakes. But for that person, I would have a lot more respect for them having a good grasp of mathematical concepts. I guess I'm just kind of ranting here. Maybe it's to prevent me from actually putting in real cognitive strain. So let's get started. I think that rant might have been like a defense technique to prevent me from experiencing cognitive strain, so we're just going to go right in and experience cognitive strain. Doing third grade math. All right, so fill in the blanks. 32 divided by 8 equals blank, because 8 times the blank equals 32. So this is just basic memorization of times tables, which I never really did. I'll admit I never really memorized my times tables. Off the top of my head, I want to say this is 6. But the real quick and clear memorization of timetables, I just don't really have. So let's verify that. So if it would be 6, then I know that 8 times 3, that's an easy one to memorize. But even without memorizing, it's just 8 3 times. So 8 plus 8 plus 8, which is 16, which is 24. And then if it's 6, it's going to be that times 2, which would be 48. So it's definitely not 6. So the answer is going to be 4. Yep, because 8 times 2 is 16, 16 times 2 is 32. Yeah, and this one, it looks like it depends on having your multiplication table memorized. I like to do Anki flashcards, so I have like a perfect pitch deck that I have in there. So I can add the times tables back in there too. That might be just nice to have, and it might not be pretty low effort for me to actually make some progress there. Although I have Anki installed on my phone and installed on my computer, I don't have habits installed in my life that make it so that I use it regularly. I used to have those habits when I was in school, but those habits have since gone away. I'm trying to reinstall those habits by doing treadmill exercise and then doing Khan Academy on that. I think that's a really good way to get exercise and get knowledge at the same time. But as I said, I just don't have a consistent time and a consistent set of dates where I do that yet, so I'm still working on that. All right, but I got this one right. Let's go on to the next one. What problem can we solve with 42 divided by 7? So Leslie ran for 42 minutes total in 1 week. If she ran the same number of minutes each day, how many minutes did she run in 1 day? I mean, that sounds right to me, and it looks like there's only one answer, so let's just go with that without reading the other answers, because I think reading the other answers would just confuse me. There we go, and I got it right. So that's a good strategy if nobody's aware of multiple choice strategy. One good strategy is if you read an answer that is in your mind the correct answer and you're 90 to 99% sure to 100% sure it's the correct answer, select that as the correct answer and move on. Because in doing that, you save time, you get more time for the other questions, and you develop trust in your mind, which is pretty helpful, I think. And then additionally, you don't confuse yourself. You don't read the other questions and say, oh, it could have been this, but oh, now I can't remember this. And if only I could remember that one thing, I'd know if it was this or this. No, just if you read if it's the first one you read and it sounds like it's and you're sure that it's correct, you don't have any valid reason to second guess yourself, don't read the other questions, because you'll just waste time and confuse yourself. All right, next question. Which equations show the same relationship as 72 equals 9 times 8? So we know that for multiplication, the order doesn't matter. It's this. If you do 9 times 8, it's the same thing as doing 8 times 9, because you can think of it as a shape. You can think of it as a rectangle with one side being 8 and one side being 9. So the area of that rectangle is going to be the same. It's going to be 9 times 8, regardless of whether the rectangle has the longer side on the left edge or the shorter side, whether it's landscape or portrait, it's still going to have the same area. Okay, so we know that this is correct, and then same thing, this is an equality, so it doesn't matter which side it's on because they are equal. If it were an inequality, then it would matter the side, because you'd have to have the correct side being greater than or less than the other side. We know this one is not correct because this is just not correct. This would be a higher number than these two. Same thing. This is not equal to this because this is a lower number than this, and we're multiplying both of these numbers. So both of these numbers will be a higher value. Okay, now here's where it gets a little bit interesting because now this is third grade, but a lot of people coming back to this as an adult will be familiar with some geometry, with some algebra. So we know that this is the equivalent if you divide 8 or 9 by 72. It's the same answer. But that's not what's happening here. We're just changing the multiplication sign to a division sign, so it's not going to equal that. Now here's where our little bit of algebra, oh, you know what? Same, oh, I see. Okay, so we're selecting the equations that have the same relationship. I selected this one because it didn't have the same relationship, but if I do that, I would get the answer wrong. So I'm gonna unselect that. There we go, and then we're selecting the ones that have the same relationship. So this one does not, so we're not gonna select it. This one, 72 divided by 8 equals 9. Yep, so a little bit of algebra knowledge is going to go there. And then we can think of it using the rectangle as well. If we want to find, if we don't know a side of the rectangle, but we know that the area is 72, and then one side is 8, we know the missing side because we know each of the sides multiplied together give us the area. So we know that the missing side times the known side equals the area. So we can divide the area by the known side to get the missing side. And I'm trying to explain like why that is the case. I feel like I'm just saying, oh, we know A plus B equals C because B plus A equals C, and that's not really not a description of this. So what I'm going to do is finish this question, and then we'll get help, and hopefully they'll have a more clear description than the one I gave for why that is the correct answer. Okay, so here's another one. Which equations show the same relationship as 72 equals 9 times 8? So same thing, we can divide 9, and then we get the answer being 8. Oh, but now look, we got a problem here. We've got 3 answers selected, but we've got 4 answers selected, but there's only 3 correct answers. And it looks like I did make the same mistake here when I selected C, where I selected ones that did not show the same relationship instead of ones that did. All right, I got it right. So let's take a look at the step-by-step solution and maybe get a name of that rule. Let's watch this video quick because, as I said, this is one of those things where I just have memorized. I just know it's true kind of fundamentally, but So there's something in learning called recognition, and there's something in learning called comprehension. I really think at this point I have more recognition than comprehension. So I want to be able to really explain why this is true.
To you on the street and says to you, 50 divided by 5, 50 divided by 5 is equal to blank, is equal to blank. How can you think about this as a multiplication problem? Well, whatever blank is, if you multiply by 5, you should get 50. You should get 50. You should get 50. So what are we thinking about? You can say, what times 5 is 50? Well, 10 times 5 is 50. 10 times 5 is 50. So 50 divided by 5 is going to be 10. Hopefully, see the relationship. If 50 divided by 5 is 10, then 10 times 5 is 50. 10 times 5 is 50. And you do it the other way around. What is 50?
Okay, I guess the simple answer is just this equal sign means equal. It means an equal quantity of substrate independent numbers. So the answer to why you can divide one of these here is because it remains an equal quantity. All right, next question. Katie is making necklaces. Each necklace uses 5 beads. She has 25 beads in total. Which expression helps us define how many necklaces Katie can make? So 25 divided by 5, because she has 25 beads. It takes 5 beads to make a necklace, so she will only be able to make 5 necklaces. Fill in the blanks to complete the table. 5 times 3. All right. Complete each question. Okay. Divided by, yeah. Times, okay, 3. Oh, see, now this is where sometimes in math I have problems. I didn't think about this answer. I just entered in a number without actually thinking about it. And the number I entered in was wrong because my thought structure in my mind was wrong. So I know that 28 divided by 7 equals 4, but I didn't know that I was being asked to enter the result of 28 divided by 7. I just didn't think about that carefully enough, so I just entered whichever number was at the top of my mind, and for some reason the number 3 was at the top of my mind. So that's kind of one of the big problems I have in math, and we saw that happen there. Kind of, I have a little bit of a kind of an ADHD type of mind, so sometimes random stuff just kind of pops in and I lose my train of thought, and that happens when I do math. All right, but we did earn some points here, so we're at 93% now. Let's see where I can get more progress. So I can get progress here for representing and interpreting data. I can get a lot of progress for perimeter, a little bit of progress for area, quadrilaterals. Looks like there's all kinds of stuff. Okay, so yep, we'll just go through each of these tabs. I probably good for an hour here, so we'll just go through each of these tabs, and hopefully I can get 3rd grade math mastered in an hour, but we will see. Okay, so I can't get any mastery points for the above. Can't get any mastery points there. Aha, so I can get 100 mastery points if I take a test on line plots with fractions. Let's go ahead and do that. Tessa measured the distance from her house to several locations to the nearest half kilometer. Graph the measurements from the frequency table using the line plot. Okay, so here's a line plot here. So we're going to put a dot for each of these measurements here. So we've got a distance and we've got the number of places. So it looks like okay, so she measured the distance from her house, and I'm not sure what the number of places means, maybe other houses. So it looks like at a distance of 2 kilometers, there are 3 other houses. So that's going to be here, 2, 3. There we go. And then it looks like so is there a way to reset this? Because this is not the answer I want. Okay, there we go. So then at a distance of 3.5 right here, there are 3 other places. I'm not sure what they mean by that, but the answer is 3. At 4, there's going to be 5. All right, and at 5.5, there's 2. There we go. What is the width in inches of the basketball? So we've got inches here. 1, 2, there we go. So it's going to be 9 and 9.25 so inches, and it needs to be a fraction. So what is the width in? So okay. Oh, it can be a mixed number or a fraction. I'm going to use a mixed number. I'm going to use 9 space 1 divided by 4. There we go. The weights of some strawberries are shown below. How many strawberries weigh between 1.5 grams and 11 grams? So let's take it at 1.5. So we can see these tick marks are every half. So 9.5, not 1.5. I think I said 1.5, but I meant 9.5. So how many weigh between that? So we've got none weighing 9.5. So between that we have 10 and we have 10.5, and then we have none at 11. I like how they made that easy, because otherwise that word between would be difficult to interpret. So it looks like all we need to do is count up these dots. So we've got 4 here and we've got 3 there. So we've got 7 strawberries. There we go. Jackie measured the height of all the slides on the playgrounds in his neighborhood. His name is Jack, not Jackie. To the nearest 1/4 yards. Graph the measurements from the frequency table on the following line plot. Okay, so this is in fourths. So at the 3/4, we've got 3. 1 and 1/2, we've got 6. 2 and 1/4, we've got 4. 2 and 3/4, we've got 3. Which pencil measures 2 and 1/4 inch? So all of them are greater than 2 inches. The inch measurements are separated into fourths, so we want only one of those fourths, which is pencil D. There we go. And I got some points, so I'm closer to my goal, hopefully. It looks like I'm not quite there yet for this unit. I'm at 98, so let's see how I can get some more points. So, so I only need 20 more points, and I can get 20 mastery points if I do the unit test, so let's do that. Okay, Purdy Pony created a chart and a picture graph to show how many of his friends live at each of the ranches in town. Okay, so here we go. We can see, it looks like just at first glance, these are multiples of 7. So let's take a closer look here. Horsehaven Ranch has 49 ponies. So that's represented with 1, 2, 3, 4, 5, 6, 7 ponies. So yep, 7 times 7 is 49. Yep, so I'm going to say 7. Alright, the graph shows the number of vehicles built at a factory last month. How many fewer bulldozers were built than garbage trucks and motorcycles combined? So, first thing I'm going to do is combine the garbage trucks and motorcycles. So for garbage trucks, easy, right on a line there. We've got 4. For motorcycles, it looks like we're halfway between 16 and 20, so we're at 18, so 22. So now there are fewer bulldozers. Looks like there's only 10, so there are 12. 12 fewer bulldozers, because to get the same number of bulldozers as garbage trucks and motorcycles, of which we counted and saw there were 22, since there are only 10 bulldozers, you would have to add 12 more to get the same number. So there are 12 fewer bulldozers. The lengths of some caterpillars are shown below. How many caterpillar lengths measured 4 3/4 inches? So we've got 4 here. This is separated into fourths, so 1, 2, 3. Here's the 3/4 mark. We've got 2. Carol created a chart and a bar graph to show how many of each type of vehicle were in her supermarket parking lot. Number in parking lot. Trucks 25, vans 5, cars 40, SUVs 10. Label each bar on the bar graph. Okay, so looks like we're missing the vehicle types here, but we do have the number of vehicles in the parking lot. And then we do have the data for that, so we just got to fill out this graph. We've got the first one here in red has 10 cars in the lot. So we can see very clearly that's SUVs. And I thought it would show, okay, it's just checked in that dialog box. The second one here has 25, which you can see is trucks. Then we've got 40, which is cars. And then the last one, 5, is vans. What is the height of the tower? So again, these are separated into fourths. So we've got 4 inches with the horses there, and then 1, 2, 3, so 4 3/4 yards. And we're going to represent that as a mixed number here. So we'll do 4 space 3 divided by 4. Whoop, and my keyboard's a little bit shoddy. I like spilled some stuff on it, so I've tried to get like a spill-proof keyboard, but anyways, I'm doing that. I think it's a defense mechanism or whatever to so maybe I need a break, maybe I need a quick break, but yeah, it's been about half an hour, so I might take a 3-minute break once I hit the half an hour. But right now let's do one more problem. Some students at Darren's school signed a petition asking for a reading area for recess. The graph below shows the number of signatures from each grade. So one of these values here means that there's 2. So how many total signatures are on the petition? So we can count up each of these, and each of these represent 2. So we could do 2, 4, 6, but I'm just going to count it by 1 and multiply my ultimate answer by 2. So here we've got 5, a group of 2 and a group of 3 equals 5. And then here we've got 7, we've got 2 groups of 7, so that's going to be 5 plus 14 equals 19, and then here we've got an extra one, 20, So another thing we could do is say put this one up there and then put these three there. Oh, we've got 20. We've got 20. Yep, 20. So I'm going to go with 20 check marks on this graph here, with the y-axis being school grade and the x-axis being number of signatures. But since we know each of these marks represent 2 signatures, my answer will be 40. Measure the length of line to the nearest 1/4 inch to collect data for the line plot below. Now record your measurements in a line plot. Okay, so so we've got 4 pencils here of different lengths. It looks like we've got 2 pencils of length 5 3/4, and these are in fourths, so there we go. Then we've got 1 pencil here of length 5 1/4. Perfect. And the final pencil is length 4 3/4. Okay. Nora's class is sending cards to children staying at the local children's hospital. Below is a picture graph that shows how many cards her class sent each month. So one of these marks equals 9 cards. Complete the chart using the picture graph. So we're going to go with number of cards sent. These each represent 9 cards sent. So in September, there were 1, 2, 3, 4, 5, 6, 7 groups of 9 cards sent. We know 7 times 10 is 70, but we're only going to times it by 9, so we can subtract one of those 7s from the group that from the amount of times we times it by. So now our ultimate answer is 63 cards sent. In November, we had 1, 2, 3, 4, 5, 6, 7, 8 cards sent. So that was one additional group of so if there were 9 cards, if there were 10 cards sent, or if each of these represented a group of 10, and we had 8 groups, that would be 80, but we have 1 fewer, so it's going to be 72. There we go. Another thing we could do is add 9 to this quantity, because we have 8 here, and then we have a quantity of, or 7, we have 7 here, and then a quantity of 8 here, so we could just add another 9 to there. There we go. So now in January, we've got 1, 2, 3, 4, 5, 6, so 6 times 9. That would be 60 if it were times 10, so we can subtract one of the 6's, we get 54. We can also subtract 6 from this answer here to get there. March, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's freebie, 10 times anything. You just add a 0 at the end. So we've got 90. May, so we know there's 10 here, and there's 1 more, so there's going to be 11. So it's going to be 99. There we go. Which pencil measures 5 3/4 inches? So here we go. 1, 2, 3. We know it's pencil A. All right, and I think I mastered this part of the section. Yep. So I got my 20 mastery points, and now I'm 100% mastered. So next is perimeter. I'm feeling a little bit cognitively drained, so let's set a timer for 3 minutes. All right, and I'll be back when this timer expires. This is the Pomodoro technique, so I'll see you soon. All right, timer is expired, so I'm back after a very quick break. I just got some water. I did a little bit of like kind of a yoga routine, so I'm feeling a lot better to continue. I want to do at least an hour. So next is perimeter. I've got lots of points to go after for this, so let's see what I can do to get the most number of points. So it looks like to get the most number of points, I can do the unit test. So let's do that. I can get up to 300, which would take me all the way there. Perfect. If I get all of these right. So the figure below is made of rectangles. Label the missing side length. So we should know what the perimeter is. Oh. Okay, this is actually pretty easy. This is an easy question. We know that the side length here, even though this is missing, it's given to us, it's 6. All the way to the edge is 6, because it's got to match here, because we know it's a rectangle. So we know that the missing side length here is going to be the side length here minus 3, it's going to be 7. Yep, because if we would add the side length here, it would be, yeah, so, oh, but now we need to know the perimeter. But the reason this side length is 7 here is because the figure is made up of rectangles. So we know that this here is a rectangle. This whole shape here is a rectangle. And we know that this shape is a rectangle here as well. So rectangles have equal sides. So we know that this side is 3. And then we know that whatever here is going to be equal to 10 when we add 3 to it, which is 7. And then since it's a rectangle, this side is equal to this side, so we know this side is 7. But the perimeter is just all the sides added together, so it's going to be 9 plus 7 is 16, 22, 32. Oh, I gotta label this first. Label it 7. There we go. 32 is the answer. There we go. Gina is getting a new bathroom mirror. The rectangular mirror measures 6 meters by 8 meters. What is the amount of space the mirror will cover in the wall? Okay, so that's going to be the area of the mirror. We know that the area of a rectangle is equal to each of its sides multiplied. Actually, that's wrong. The area of a rectangle is equal to the length and the width of the rectangle multiplied together. Each of the sides multiplied together does not equal the area because you would be multiplying 4 numbers because a rectangle has 4 sides. You only need to multiply 2 numbers, the area and the width of the rectangle to get, the length and the width of the rectangle to get the area. So the amount of space the mirror will cover on the wall is the area of the mirror, which equals 6 meters times 8 meters, which equals 48, I think. So 3 times 8, so yeah, 48. Okay, so a square has a perimeter of, now this is a square, so all sides are equal. And this is the perimeter, so all sides added together equal 48. So what is the length of one side in the square? So basically, what times 4 equals 48? We know that 8 times 4 equals 48. Okay, wait, 8, oh, sorry, 8 times, the answer is, you see, this is where I don't have my multiplication tables like completely memorized. I should probably fix that. So a square has a perimeter, so what times 4 equals 48? Let's think about what, so 8 times 4 is equal to 2 times 8 is 16 is equal to 32, so we need a bigger number here. Yeah, 4 times 4, or 10 times 4 is going to be 40, So it's actually going to be a number bigger than 10. I think it's going to be 12 because, yeah, 12 times 2 is 24, times 2 is 48. So, and this is where it gets tricky too, because even if you have your multiplication tables memorized, depending on how large of a table you memorized, you might not have this memorized. For me, from what I remember, the multiplication tables we went up to 10. But if I were to do this again as an adult, I'd probably memorize at least up to 12. But it's not a super big priority for me with like calculators and stuff. I just think math kind of helps you think a little bit better, so it's worth the time I'm putting in now for sure. But as I said, this is just a warm-up for me to get used to making videos again and get used to thinking at some level of depth again in front of a camera while making these videos. So my ultimate goal is to get back to the core content for this channel as soon as possible. Do the following sports fields have the same perimeter, area, or both? Okay, so first we're going to check if they have the same area. So 6 times 6 is 36. 4 times 9 is 36, so they do have the same area. Now let's see if they have the same perimeter. So 6 times 4 is 24. Then we've got same side here, so we've got 18. 18 plus 8 is 26. So they have the same area, but they don't have the same perimeter. Jaden folded a 66 centimeter strip of paper into 6 equal parts to model a honeycomb cells. Each part was one side of the model. What is the length of one side of the model? Okay, so he folded a 66 centimeter strip of paper into 6 equal parts to model a honeycomb. Okay, so into a hexagon. So 6 sides, each with equal sides. So what is the length of each of them? So we're going to do 66 divided by 6, so 11. There we go. Natalie runs the outside of a square park in her city. Each side of the park measures 20 meters. How far did she run? So she ran the perimeter of the park. The perimeter is each side added together. It's a square, so each side is of equal length, and the length of one side is 20. So 24, she ran 80 meters. The perimeter of the figure is 26 centimeters. Figure is not drawn to scale. Yeah, okay. What is the length of the missing side? So we know that, oh, this is kind of interesting. So we know that it's a, oh, I guess we don't know that it's a, rectangle. We know the perimeter, so we can add all these sides together, and then we'll know what the missing side is by subtracting the perimeter, or by subtracting the sum of all of the known sides minus, or by subtracting the sum of the known sides from the perimeter. So the sum of the known sides is 14, so it's 21. So 26, the perimeter, when we subtract that 21 from the perimeter, which is 26, we're going to get an answer of 5. Do the following rectangles have the same perimeter area of both? So we'll start with the area. 6 times 6 is 36. So they do have the same area. Do they have the same perimeter? So 6 times 4 is 24. Now we've got 8 plus 18 is 26, so they only have the same area. Curie is putting a frame around the greenhouse panel below. How many centimeters of frame does Curie need? So they need, for each of the sides, they need this number of centimeters. So the perimeter is what they're asking about. So we just add these together. We get 131 plus 100 is 231. So let's just write this out here. Looks like it doesn't come with a calculator, so let's not use one. We're gonna do 190 plus 25 plus 100 plus 131. And then we'll simplify this. So we're gonna do 231. We'll simplify this as well. So 18, so this is going to be 285, I believe. And then this is going to be 6 in the last digit. The second digit is going to be 12. So it's going to be 526. So my mental math needs some work, which isn't surprising. Because I use calculators whenever. I would have used a calculator for this if I weren't doing this as like an exercise. Okay, so let's think about these numbers again. Let's write them down again in this box. Okay, let's do the simplification again of that number. Okay, and now let's think about what it means to add these numbers. So if we added this by 100, we would get 331. But if we did that, we would be adding an extra 5. So to come away with what the actual value is, we can subtract that extra 5 that we used to make that addition easier. And that gives us 326. Okay, so now similarly, if we added 10 to this, we'd get a nice even number, 526, but then we'd have an additional 10 to our answer, so we want to get rid of that extra 10, and now we've got 516. There we go. Okay, so I got some points there, not all the way mastered. Looks like I can get 150 if I do it again, which would be enough to have this 100% mastered. I'm at the 48-minute mark of this video. Yep, this might be the last thing I do in this video. Let's take this again and see if I can get everything correct. Sally is building a garden. She plans to build a rectangular garden measuring 6 meters by 8 meters. She wants to put a net over the top of the garden to keep the birds out. She has 12 square meters of netting in her garage. How much more netting will Sally need to cover her whole garden? And you can see the power of this. You know, this is a 3rd grade level, but I'm an adult going back to the 3rd grade. So this is a clear example of why I'm not embarrassed to do this sort of thing. If you're an adult, you know, you might be gardening. If you're gardening, you might need to know how much netting you need. So having practice with this and being able to incorporate it and bring it into your real life and not just be like, oh, I'll just eyeball it or whatever, can be really valuable. So this is a good question. Okay, so how much more netting will Sally need to cover her whole garden? So she needs 18. She has 12. So she's going to need 6 more square meters. The following figure is made of a triangle and a rectangle. All sides of the triangle are the same length. What is the perimeter of the figure? Okay, so all of these sides are the same length, so we know the side is 3. We know the side is 3 as well, but we're looking for the perimeter, so we don't need to count this side. We know that this is a rectangle, so we know that this is the same. So we've got 22 plus 3 is 25, plus 6 is 31. Chris puts 2 layers of cake next to each other. The layers each measure 20 centimeters by 20 centimeters. The figure below shows the cake. What is the perimeter of the cake? So the perimeter is all of the outer sides added together. We do have an inner side here, but that's not going to constitute the perimeter. It's not going to be taken into consideration when we calculate the perimeter of the cake. If we wanted the perimeter of 1/2 of the cake, then we would take this side into consideration, but we want the perimeter of the whole cake as if it were one piece and not 2 pieces next to each other. So it's going to be 60 for this side and this side, and then this is half of it, so we know this is 40, and then we know this is the same, so it's 80, so it's going to be 60 plus 80, which is 120. Oops, and maybe my mental math was wrong. Sure enough, 60 plus 80 is not 120, it is 140. Oops, and that's just my keyboard. Yeah, so I need a little bit of practice with mental math sometimes. As I said, I kind of have ADD brain or something, and my and I'm just used to using a calculator. I don't do a lot of mental math. I just use the calculator. So this is good. This is good. All right, on to the next one. A regular octagon below has a perimeter of 80. What is the length of one side? So it's an octagon, so it's got 8 equal sides. Each of those equal sides, 8 of them added together, gives us a perimeter of 80. So we know 8 times 10 equals 80, so each of those sides is 10. Do the following notebooks have the same perimeter area or both? So this is 40. This is 40 as well, so they have the same area, but the perimeter is going to be 20 plus 8, 28. Here's going to be 10 plus 16, 26, so they have the same area only. A regular pentagon has a perimeter of 20 centimeters. What is the length of one side of the pentagon? Okay, and it's a pentagon, so that means there's 5 equal sides. So it's going to be 4 centimeters. 4 times 5, the length of 4 for each of the 5 sides. So 4 times 5 gives us the perimeter. The figure below is made of rectangles. Label the missing side length. So it's going to be 10, 6 plus 4. And then what is the perimeter? It's going to be 20 for these sides, 25, 26, 27, 30, 34. Oops, so there's my mental math getting in the way again. It looks like I already included this side when I did this, so if we just subtract 4 from the answer, we'll get the right one, which is 30. There we go. I included that side twice when I added all the sides. Steph needs to help her parents to put a fence around their pool. They want the fence to be square and want each side to measure 6 meters. They already have 10 meters of fencing. How many more meters of fencing should they buy? So they want a perimeter, and they want each side, they want a square perimeter with each side being 6, so 6 times 6, so 4 times 6 is 24 2 times 6 is 12. 12 times 2 is 24. They have 10, so they're going to need 12. They're going to need 14 more meters of fencing. Okay, do the following rectangles have the same perimeter area or both? It looks like so this has an area of 8. This has an area of 8, so they do have the same area. There's a perimeter of 8, 10, 12. Perimeter of way more than that, so same area only. Okay, and let's see how many points we got here. So we got quite a few points, but not enough to have everything mastered yet. But it looks like we can take it one more time and get the 110 mastery points that we're missing. So let's do that. I'm at the 55 mark on this video, so I might be due for another break. I'm feeling pretty good. I just have maybe a little bit of back pain, so I might want to do another quick stretch routine. Do the following pictures have the same perimeter area or both? So the area is the length and the width multiplied, so that's 36. Here that's 35, so they don't have the same area. The perimeter is all sides added, and there are 4 equal sides since this is a square, and we know that it's a square because these are the same length. So it's going to be 4 times 6 is 24, and then here we're going to add 14. So they do have the same perimeter, but they don't have the same area. The following figure is made of 3 rectangles that are all the same size. What is the perimeter of the figure? So 12 times 3 is going to be 36. 36 times 2 is going to be 72. Plus 7 is 79. Plus another 7 is going to be 86. And this is where I have weakness in doing this mental math, so let's see if I got it. I did. Okay, cool. I might have wanted to just do it again just to make sure my mental math weakness wasn't creeping in, but I felt pretty confident. All right, the perimeter of the figure is 24 centimeters. Of course, I feel confident when I get it wrong too. What is the length of the missing side? So, okay, so we know the perimeter is 24. So this is 8 plus 14, 29. So it's going to be 5. There we go. Mental math is doing good. Tom wants new carpeting for his bedroom. His room is a 9 meters by 7 meters rectangle. How much carpeting does he need to buy to cover his entire bedroom floor? So that would be the area. The sides are 9 and 7. The length and width is 9 and 7. So 9 times 7, if it were 10, it would be 70, but we're going to do one less 7, we're going to do 9, so it would be 63. Tony runs around her school's baseball diamond. Each side is 27, and it's a diamond, so that means there's going to be 4 sides, or it's a square, just rotated. So how far does she run? She runs 4 lengths of 27, so 2 lengths of 27 is going to be 54, and then 2 lengths of 54 is going to be 108. Okay, I was not feeling confident about that because of the struggles I've been having with mental math, but I got it right, so let's move on. The figure below is made of rectangles. Label the missing side length. So it's going to be equal to these side lengths together, because we know this is made of rectangles. So it's going to be 2 plus 5 is 7 equals 8. What is the perimeter of the figure? So it's going to be, now let's not make the same mistake I did before. We're just going to go around and add each number instead of just taking this 8 and then not counting this a second time. We're not going to make that mistake again, so we're going to start with the 8 here. 8 plus 7 is 15. We've got 16, 17, 18, 23, 27, 28, 29, 38. Perfect. The regular pentagon below has a perimeter of 55. What is the length of one side of the pentagon? Pentagon has 5 sides, so 5 times 11 is 55. So one side is going to be 11. Do the following rectangles have the same perimeter area or both? So the area here is 20, area here is 20. They have the same area, but this is 10 plus 8, which is 18. And this is way bigger a number than that, so they have the same area only. Alex jogs around the building below, which is the U.S. Pentagon building where national security stuff is done out of. Each side of the building is 200 meters long, so there's 5 sides, so times 5. So 10,000 meters. And now this is one where I'm second guessing myself. So let's do 5. Let's just do this here. So 5 times there. So yep, I would have gotten this wrong. The correct answer is 1,000. Yeah, because we can count 5 times by this. So we can do 200. 400, 600, 800, 1,000. Perfect. Oh, where are my points? Oh, I guess I still have another 20 points. Oh, sometimes I need to refresh. Oh, looks like I'm missing 20 points. So I can take this and I can get the 20 points I'm missing. So let's do that. Oh, sometimes it's a little bit buggy. So let's go back. Yeah, let's go back here and we'll go to the perimeter. It looks like I still am missing 20 points. Well, I can get 20 points here. There are no more levels to reach. Alright, well, you know what? I'll just move on. The next part is area. So let's try to get 100% in that. It looks like I'm over the 1 hour mark, so now I need to choose if I want to take another 3-minute break and to go to the 1.5 hour mark, or if I just want to call it good. I'm at 1:10 p.m. on a Sunday, so I can do pretty much whatever I want. So you know what? I want to do another half an hour, so I'm going to do a 3-minute break. And then when I come back, I'll do another half an hour doing 3rd grade math in this video publicly. Alright, so I'll be back in 3 minutes. Okay, I'm back. I'm feeling a lot more energized. So I just want to do one more half an hour. I don't want to spend my whole day doing 3rd grade math. Alright, so let's continue. This is learning more about the area of a 2-dimensional shape. So, okay, so we can get 100 mastery points by doing that. But we can get 200 by doing the unit test, so that's all I need. So let's try to get everyone right. I think I understand area pretty well, so hopefully this will be a freebie here. So each Unit is 1 square, so we've got 1, 2, 3, 4, 5, 6. 1, 2, 3. That's going to be 18. Okay. Now we got to see what the area is here. If it were a rectangle or a square, we could multiply the length by the width, but we can see it's just a polynomial. It's not, or sorry, it's a shape that is not a rectangle nor a square. So what we could do is separate it into two shapes. But since we know the values for each individual one of these squares in the grid, all we need to do is simply count the square meters that constitute this shape, and then we get the number of square meters that constitute the area of this shape. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, a rectangle has an area of 32 square meters, and the length of the rectangle is 6. What is the width? So it's going to be 4, because 4 times 8 is 32. Each square in the figure below has an area of 1 square unit. We can break the figure into 2 parts and complete the equation to find the area of the entire figure. So area equals So the area is going to be 8 times 4. So I guess this is going to be 2 4s or 4 4s. Wait, I'm confused. Oh, I see. So this 2 4s here, and we can see it's actually the same color too, is describing this one. So now we need to describe this shape here, which is 6 4s. Okay, so 2 times 4 is 8. 6 times 4 is 24. So our answer is 32. Now I'm not feeling very confident about this answer, so I'm feeling over 50% confident. I would say 70, 75. So there we go. The reason I wasn't feeling confident is because of my, as I mentioned, first of all, my understanding of what it was asking. I wasn't very confident about that. And then my kind of multiplication table memorization too, I wasn't very confident about. But I was more than 50% confident by a pretty large margin, so I decided to see if I got it right, and I did. So let's go to the next one. The figure below shows a large rectangle with a small rectangle cut out of it. What is the area of the shaded figure? So the area of the shaded figure is going to be the length and the width. 8 times 7 equals 56, minus the area of the cut out portion, which is 2 times 3, which is 6. So the area of the shaded figure is 50. What shapes have an area of 12 square meters? Which shapes have an area of 12 square meters? So 1, 2, 3, 4, 5, 6. So this has an area of 12 meters. We only need 2. This looks a bit tricky, so we'll save that one to the end. If there's no clear answers, we can come back to this one and kind of try to work it through. This one too, so this is the other more simple one. So let's see if it has an area of 12. 3, 4, it does. So we don't even have to look at these now because we've already got 2 answers that I am more than 99% confident are correct. Searching Shreya and Traveling Tim are setting out to explore with their treasure maps shown below. Traveling Tim, okay. Which treasure map has the larger area? So this has an area of 70, and this has an area of 72. So the Traveling Tim treasure map has the larger area. Each small square on the grid has an area of 1 square unit. Move the corners of the figure around to make a rectangle with an area of 15 square units. Okay, but each is 1, so we need to make 15, so that's going to be 3 times 5. There we go. So now the area is 15. We've got a row of 5. We got 3 rows of 5. There we go. Which expression shows a way to find the area of the following rectangle? So it's a rectangle. We can see we've got 4 divisions here. So this is presumably a length of 8. And we've got 5 here, presumably a length of 5. So 8 times 5 would do it. And that's, we don't, again, as I mentioned before, good multiple choice technique. I'm 99% plus confident this is the right answer, so I don't even have to look at the other ones. It would just confuse me and waste time. Which figure has the greatest area? So this is 1, 2, 3, 5, 10, 13, and this is 9, so A has the greatest area. How do we know which figure has the greatest area? It covers the most space. Yep. Okay, perfect. So I have, oh, it's withholding 40 points for me now. I think it's just a bug. I think sometimes it gets a little buggy, and I think I do have full points in this. It just sometimes is a little buggy. Yeah, because it says I mastered it. So let's move on to the next one, which is quadrilaterals. Let's take a look at how, yeah, I'm at 97%, so I'm definitely making progress. Okay, so let's try to get 100 mastery points in the quadrilaterals section. I can do another. This video is going to be about an hour and a half, so I've got a little bit longer than 15 minutes to go. How do we classify the following shape? So it's got 4 sides of equal length, but there aren't 90-degree angles here, so it's not a square. Rectangles don't have equal sides. It has a different length and width. And then a quadrilateral, I think, is so that it doesn't do anything. So this is a rhombus. I need all answers that apply. Oh, it's also a quadrilateral. A quadrilateral is more like an umbrella term, so it has 4 sides. There we go. And that didn't count against me, so hopefully I'll still get full points. What do all these shapes have in common? They are all quadrilaterals. Yeah, but again, that's just a generic term, so so they're not all rhombuses because this has all 90 degrees. They're not all rectangles because the length and the width are different on this one. They're not all squares because they don't all have equal sides as this one does. So the answer is none of the above. How can we classify the following shape? So it's definitely a quadrilateral. We've got 4 sides. It's definitely not a rectangle because we've got these angles don't appear to be 90 degrees. So it's a rhombus, and it's not a square for the same reason, and it's definitely quadrilateral, so it's not none of the above either. Oh, I got this wrong. Rectangle, maybe? I'm confused now. What? Okay, so there must be something wrong with this question because we can see to choose all the answers that, oh, maybe I've got that apply. Oh, I don't understand why it's not a rhombus. Maybe because the bottom side isn't flat. But I think the correct answer for this is it's only a quadrilateral, it's nothing else. Okay, that's right. So a little bit more practice with that. All of the shapes have 4 equal sides. Which of the following shapes belong in the group? This one, because it's a shape with 4 equal sides. How can we classify the following shape? Choose all answers that apply. Now this is definitely quadrilateral, and I think this is definitely a rhombus because of its orientation. It's got the it's got a side on the bottom that is flat. Oh. Okay, I'm a little bit confused as to what a... Oh, you know what? Okay, let's take a look. This is the second time I got this one wrong. So, so a quadrilateral is a polygon is the word I was looking for before. Polygon with 4 sides, definitely a quadrilateral. Rectangles are quadrilaterals with 4 right angles. You know, it's definitely not that. Rhombuses are quadrilaterals with 4 sides of equal length. Oh, okay. Okay, now I understand. Look at the following shapes. What do these shapes have in common? I would say that they're definitely all quadrilaterals, that's no doubt. But they're also all squares. Now where it gets tricky, I'm not sure if they're all rectangles. I'm not sure if a square is or is not a rectangle. I think a rectangle has different lengths than widths, so I don't think they're rectangles. Nope, they're rectangles. All squares are rectangles. I thought a square could not be a rectangle because it had the same length as width, but that is not true. A rectangle is a quadrilateral with 4 right angles. So all squares are rectangles. A square is a quadrilateral with 4 equal side lengths and 4 right angles. Okay, all squares are rectangles. These are all rectangles, but not all rectangles are squares because some rectangles have different lengths than widths. Some rectangles have the same lengths and widths. Those rectangles are squares. But the rectangles that have different lengths and widths are rectangles, but are not squares. How do we classify the following shape? Quadrilateral, it's a square, and we know because it's a square, it's a rectangle, but even if we didn't know it was a square, we can see there are 4 sides with 90-degree angles. Oh, come on, really? Wait a minute. Is it also a rhombus? Oh, it's a rhombus too. What the heck is a rhombus? Rhombuses are quadrilaterals with 4 sides of equal length. Oh, okay. So rhombuses don't necessarily have to. Okay, I guess all squares are rhombuses, but not all rhombuses are squares. I'm confused now. They have nothing in common. Quadrilateral. Oh, no, it's not. It's not. It's got more than. It's got 5 sides. Okay. Okay, so let me do this one more time. I've got about 9 minutes. And I might be able to get, now that I've got the cobwebs off my brain, this might be better. Which of the following shapes belong in this group? So all these shapes have 4 sides, so we can immediately eliminate the shapes that have more than 4 sides, such as this one, and this one, and that leaves us with just one answer. We've only got one answer to choose, so we've already chosen it, so we got it right. Let's move on. How can we classify the following shape? Okay, so now this is what gets tricky. It's definitely quadrilateral. That's the easy one because it's got 4 sides. It's definitely a rectangle because it appears to have all 90-degree angles. It's definitely a square because it appears to it has all equal sides. And it's definitely a rhombus as well because a rhombus has all equal sides, but it doesn't necessarily have all equal angles. But if it does have all equal angles, it's still a rhombus. There we go. Look at the following shapes. What do these shapes have in common? So 1, 2, 3, 4. So they've all got 4 sides, so they're all equilaterals. They're not all rectangles because this one doesn't have all equal angles. They're definitely not all squares, so this is the only correct answer. How can we classify the following shape? So we know it's a quadrilateral. We know it's a rectangle because it appears to have all equal angles. Does not have all equal sides though, so we know that it is not a rhombus. And it does not have all equal, and although it does have all equal angles, because it does not have all equal sides, we know that it is neither a rhombus nor a square. Here we go. The following shapes all belong to the same group. All of the shapes have 4 sides and 4 angles. Which of the following shapes belongs in the group? Okay, so they've all got 4. This has more than 4. This has 4, 3. Okay, so we're left with one answer, so that's the correct answer. How can we classify the following shape? So we know it's a quadrilateral. We know it's not a rectangle because all of the sides don't appear to be the same. So we know it's also not a square for that same reason. But rhombuses have to have all equal sides, but they don't have to have all equal angles. We see all equal sides here, so we know it's a rhombus. There we go. Look at the following shapes. What do they have in common? So they all have 4 sides, which means they're all quadrilaterals. They all have, they're all rhombuses. A rhombus means that all the side lengths are the same. We can see that's true. Now are they all squares? So we see two of them are squares because we've got all equal angles, but this one is not, so that's not true. And then we select these two answers, so we know E is not correct either. There we go. How can we classify the following shape? So it's got four sides, so it's a quadrilateral, but all of the side lengths are different, and then the angles appear to be different as well, so it is neither a rectangle, rhombus, nor is it a square. The following shapes all belong to the same group. All of the shapes have four equal sides and four right angles. Which of the following shapes belongs in the group? Okay, so here's a shape with four equal sides and four equal angles, so it belongs to the group. Okay, so if we take it one more time here, we can get 50 points, which is the 50 points we're missing. I've got about 5 minutes. That last one didn't take me too long, so let's just do it again. How can we classify the following shape? It's definitely a quadrilateral. We know it's definitely a rectangle because it appears that all the sides are the same, or sorry, all the angles are the same. The sides are different, so it's not going to be a square, nor is it going to be a rhombus. Look at the following shapes. What do these shapes have in common? So they're not all rhombuses. We know that because they have different sides. They're not all rectangles. We know that because they don't all have 90-degree angles. And they're not all squares, both because they don't have all 90-degree angles and because they don't all have equal side lengths. So none of the above. How can we classify the following shape? So we've got four sides, so it's definitely quadrilateral. I'm not sure what yeah, I don't think these are 90-degree angles. I should be more clear about that. So I don't think it can be a rectangle or a square. So I think it's a quadrilateral. It's a rhombus because I don't think these are 90-degree angles. Okay, got it right. The following shapes all belong to the same group. So we need a shape with four sides. We've got two to choose from, so now we need more additional criteria. They all have the same side lengths. This one has different side lengths, so it's going to be A. How can we classify the following shape? So it's got more than four sides. Yeah, it's none of the above. Look at the following shapes. What do these shapes have in common? So they've all got four sides. They're all quadrilaterals. They're not all rhombuses because some have different side lengths. And then they don't have 90-degree angles, so they're not rectangles. So they are all quadrilaterals. How do we classify the following shape? Definitely a quadrilateral. Definitely a rectangle because it's all 90-degree angles. Definitely a rhombus because all the side lengths are the same. And it's also a square because all of the side lengths are the same and all of the angles are the same. The following shapes all belong to the same group. All the shapes have four equal sides. Which of the following shapes belongs in the group? So we need a shape with four sides. So all of these shapes have four sides, so we need additional material matching criteria besides that. All of the shapes in this group have equal side lengths, so this one doesn't have equal, not equal, equal, not equal. So we're going to go with C. How can we classify the following shape? So definitely quadrilateral, four sides, that's the easy one. Definitely a rhombus because we've got equal side lengths. But it looks like we don't have those 90-degree angles, so it's neither a rectangle nor a square. Alright, and I got my missing points hopefully, so... Aha! Yep, I'm at 100%. Alright, and I'm just about at the... Yeah, and we can see we got the bug here too, where it's not giving me 100% for whatever reason, even though it says I already have it. But that's okay. I should submit a bug report. I'm going to do that. How do I do that? It's kind of too late. I lost it anyway. I can't take a screenshot. Or maybe help. Yeah, report a problem. Yeah. Okay, so unfortunately it's not going to be the most helpful thing, but we're going to say unit test completed 100%, but 20 points still missing, unable to collect. Description: when I complete the unit test for a what is this called? For a unit. When I complete the unit test and get 100% mastery points for a unit, although the unit test section says test rectangle says I have 100% points and can no longer take the unit test. The upper left mastery points meter says I still need to earn 20 points to achieve mastery. There is another rectangle on the page that says it's worth the 20 points I am missing, but when I try to take the test for the missing 20 points, it says that there aren't any more points to earn. Yeah, so we can see that here. If I and I closed it, so this is not relevant to that. Okay, so that's what I remember, so I'll just write that down there. I'm not even sure if they will even see this. So yeah, so there we go. It looks like they have a whole category for this. So okay, so if needed, yes, they primary as a learner. How are we using teacher, independent learner, using device. I'm using a laptop. I'm using I'm using Linux. What browser? I'm using Chrome. Oh, the most relevant page. I mean, that's good. Well, the perimeter one was doing that, so I'll link that one. There we go. Yeah, and we can see it still has it. And if I click on the 20, yeah, here it says I can't do it. Yeah, it says I've achieved mastery. But yeah, and then if I click here, already proficient. Yeah. Okay. So that puts me at well over the 130 mark. So that's going to be it for this video. Not the core kind on my channel, but I haven't been making videos for a while, so I just wanted to get back in the habit and kind of taxing my brain in more of a manageable way, instead of just diving into RFCs and fumbling around on the lab, getting really frustrated and feeling like I'm going nowhere, reading the books and not getting the tutorials to work. So yeah, I feel really good about what I did. Kind of brushing up on math, I think, is always a respectable thing to do. So thanks for watching, and I'll see you in the next one.